Right now, almost 3,000 kilometers beneath your feet, two enormous objects are buried deep inside the Earth. Each one is the size of a continent. Each one is twice as big as the entire moon. And they are made of something that doesn't quite match the rest of our planet. Something stranger, denser, and older. For decades, scientists had no idea what they were or where they came from. They just sat there in the dark, near the molten heart of the world, refusing to be explained. But a stunning new idea suggests something almost too wild to believe. That these two giant blobs are not part of the Earth at all. They are the broken remains of another planet. A lost world that slammed into ours over 4 billion years ago, died, and was swallowed whole. And it might be the very reason you're alive to hear this. Today we're going on a journey to the center of the Earth to meet the corpse of a dead planet hiding inside our own. Stay with me, because the twist in this story rewrites where the Earth and you actually came from. Let's go. First, let's get our bearings. Because to understand this, you have to understand just how little we actually know about what's beneath us. We have walked on the moon. We have sent probes hurtling past Pluto, billions of kilometers away. But the deepest hole humans have ever drilled into our own planet reaches down only about 12 kilometers, barely a pinprick in the skin of an apple. The Earth's radius is over 6,000 kilometers. We have never come remotely close to touching its interior. So how could anyone possibly know that there are two continent-sized objects buried near the core, almost 3,000 kilometers down? We can't see them. We can't dig to them. We will likely never touch them, and yet we know they're there. The way we found them is one of the cleverest tricks in all of science. The answer is earthquakes.
When a powerful earthquake rips through the planet, it doesn't just shake the surface, it sends seismic waves blasting straight through the entire body of the Earth, in every direction, like ripples through a struck bell. And here's the crucial part. Those waves change speed depending on what they're traveling through. Move through cold, stiff rock, and they speed up. Move through hot, soft, or unusual material, and they slow down. So all around the world, sensitive instruments record these waves as they emerge on the far side of the planet, having passed all the way through. By comparing how long thousands of these waves took and how their speeds changed along the way, scientists can essentially build a three-dimensional map of the inside of the Earth without ever digging a single hole. It's a kind of planetary medical scan, an ultrasound of the entire world, using earthquakes as the light source.
And in the 1980s, when researchers first assembled these scans in enough detail, they saw something they did not expect at all. It's worth pausing on just how remarkable this technique is, because it's the only reason we know any of this. Every single day, the Earth trembles with earthquakes, and each major one sends out two main kinds of waves that race through the planet's interior. Some waves can travel through both solid rock and liquid. Others can only pass through solids, and they're stopped dead by the molten outer core. By watching where certain waves mysteriously fail to arrive, casting a kind of seismic shadow on the far side of the Earth, scientists first proved over a century ago that our planet even has a liquid core at all. They had X-rayed the Earth using nothing but earthquakes. Modern researchers took that same idea and supercharged it, pooling data from thousands of seismic stations and millions of waves over decades, until they could resolve features deep inside the planet in stunning detail. This field is called seismic tomography, and it has effectively given us eyes that can see straight through 6,000 kilometers of solid rock. Without it, the two blobs would be utterly invisible to us. We'd have no idea they were there at all. Down at the very bottom of the mantle, right where the rocky interior meets the searing liquid metal of the outer core, the seismic waves were doing something strange. In two vast regions, the waves were slowing down dramatically, as if they were plowing through some kind of thick, heavy sludge that didn't belong. These two zones were not small. Each was the size of a continent, sprawling across the base of the mantle. One sits beneath the continent of Africa. The other sits on the opposite side of the planet, beneath the Pacific Ocean. Scientists gave them a deliberately dry, technical name: Large, low-velocity provinces, or LLVPs, named for the way they slow those seismic waves down. But that bland name hides something extraordinary, because the more we studied these blobs, the weirder they got. Let's talk about their sheer scale, because it's genuinely hard to hold in your head. These are not little pockets. Each of these two blobs is around twice the size of the moon. If you could somehow scoop them out and spread their material in an even layer across the surface of the Earth, it would coat the entire planet in a shell of rock roughly 100 kilometers thick. They are among the single largest structures inside our planet, and they rise up off the core like vast mountains of the deep, towering masses of material standing in the dark, far larger than anything on the surface we'd ever call a mountain or a continent. For something so colossal to be sitting inside the Earth, and for us to have only discovered it a few decades ago, tells you just how mysterious our own planet's interior still is. But size was only the first puzzle. The really troubling thing was what they appeared to be made of. The blobs aren't just hotter than the rock around them, they also appear to be denser, heavier, and chemically different from the normal mantle. They seem to contain different proportions of elements, in particular, a higher amount of iron. And that's a genuine problem. Because the Earth's mantle has been slowly churning and stirring for billions of years, like an impossibly slow-motion pot of boiling soup. Over that much time, you'd expect anything unusual to get mixed in, blended, smeared out, and erased, homogenized into the same uniform rock as everything else. Yet here are these two gigantic clumps of distinct, alien-seeming material that have somehow refused to blend in. They've stayed separate, stubborn, and intact, sitting at the bottom of the mantle for an unimaginably long time. The question screamed out, where did they come from, and how have they survived? And there's a detail that makes them stranger still. The two blobs aren't even identical twins. Seismic maps suggest the one beneath Africa stands taller and may be less stable than its partner under the Pacific, as if the two giants have aged differently over the eons. Scientists have even wondered whether the towering African blob could be influencing what happens far above it on the surface, where the African continent is slowly being torn apart along a great rift. Imagine that, a structure buried nearly 3,000 kilometers down, possibly reaching up through all that rock to help reshape the map of the world we live on. And one more clue would prove crucial to cracking the mystery: the chemistry. That higher iron content isn't a random quirk. It would turn out to be a fingerprint, a chemical signature pointing back to where this material was forged. But to read that fingerprint, scientists had to look in a very unexpected place, not down into the Earth, but up at the moon. For years, scientists offered more ordinary explanations. Maybe the blobs were graveyards of old tectonic plates, slabs of the Earth's surface that had been dragged down into the depths over eons and piled up at the bottom. Maybe they were just regions that happened to be hotter, or some leftover sludge from when the early Earth was a global ocean of magma. These were reasonable guesses, but none of them fully explained why the blobs are so chemically distinct, so dense, and so stubbornly unmixed after all this time. The mystery sat unsolved for decades, and then, in 2023, a team of scientists proposed an answer so audacious it sounds like science fiction. An answer that reaches back to the most violent day in our planet's entire history. To understand it, we have to leave the Earth's core for a moment and rewind the clock 4.5 billion years. Picture the very early solar system. It was a chaotic, violent shooting gallery. The young Earth wasn't yet the finished planet we know. It was still forming, a hot, half-built world, and it shared its orbit with other young, growing planets, jostling for the same space. According to the leading theory of how our moon was born, called the giant impact hypothesis, one of those other young worlds was a planet roughly the size of Mars. Scientists have given it a name, Theia. and Theia was on a collision course with the young, still-forming Earth. Then it happened. Theia slammed into the proto-Earth in one of the most catastrophic events imaginable, a planetary collision between two worlds. The impact was so colossal that it partially melted both planets and blasted a titanic spray of molten debris out into space. That ring of glowing debris, flung into orbit around the wounded Earth, slowly gathered itself together under gravity and cooled, and formed the Moon. This is the leading explanation for why our Moon exists at all, and it elegantly explains many features of the Earth-Moon system. But it always left one nagging, unanswered question hanging in the air, a question that haunted scientists for years. If an entire Mars-sized planet smashed into us, where did it go? Where is Theia now? We could see what it produced, the Moon, hanging in our sky, but the killer planet itself seemed to have simply vanished. Its body was missing. This is where that iron clue comes back. When scientists study the rocks the Apollo astronauts brought back from the Moon, they find that the Moon is richer in iron than you might expect. Since the Moon is thought to be built largely from the debris of Theia, that iron-rich Moon is a window into what Theia itself was made of. It tells us Theia's mantle was unusually heavy with iron. Now hold that thought next to the blobs deep in the Earth, which are also unusually iron-rich and dense. Two separate mysteries, the missing body of Theia and the strange, heavy blobs near our core, suddenly look like they might be two halves of the same answer. The Moon and the blobs may carry the same chemical fingerprint, because they may be made of the same dead planet. One piece of Theia ended up in the sky. The other may have ended up beneath our feet. And this is where the two stories collide, literally. The 2023 study proposed something breathtaking, that Theia never vanished at all, that we've been standing on top of its grave this entire time. The idea goes like this. When Theia hit the Earth, most of the lighter debris was flung out to form the Moon. But Theia's mantle was unusually rich in iron, which made parts of it especially dense and heavy. According to the new computer simulations, large chunks of this dense Theia material didn't fly off into space and didn't get evenly mixed into the Earth. Instead, because they were so heavy, they sank. They plunged downward through the molten young Earth, all the way to the bottom of the mantle, and came to rest on top of the core. And there, over 4.5 billion years, those sunken fragments of a dead planet gathered together into two great piles, the very blobs we detect today. In other words, the LLVPs may literally be the buried corpse of Theia, the planet that killed and remade the early Earth, preserved in our depths like a body in a tomb. Let that sink in for a moment. If this idea is right, then the strange, dense, continent-sized masses at the bottom of our planet are not really part of Earth. They are pieces of another world, an alien planet, swallowed and entombed inside ours, hiding near the core for almost the entire history of the solar system. The reason the blobs are denser and chemically different from the surrounding mantle is simply that they were never Earth to begin with. They're Theia. And the reason they never mixed in is that they were heavy enough to sink and stay put, sitting quietly at the core mantle boundary while the rest of the planet churned above them. How could pieces of a whole planet survive for 4.5 billion years without being stirred away? That's one of the most remarkable parts of the idea. The simulations suggest that right after the impact, Theia's dense, iron-rich material existed as blobs only tens of kilometers across, scattered through the molten depths of the wounded Earth. Because they were heavier than everything around them, they drifted downward and pooled at the very bottom of the mantle, against the core, the deepest, most stable basement in the entire planet. And here's the key. That boundary just above the core is a relatively quiet zone. The slow churning of the mantle that mixes everything else mostly sweeps by above it, leaving the heavy material below comparatively undisturbed, like silt settling at the bottom of a river while the current rushes overhead. Protected down there, the dense fragments slowly gathered and merged over the eons into the two great piles we detect today. They didn't survive in spite of being heavy and deep.
They survived precisely because they were heavy enough to sink below the reach of the churning that would otherwise have erased them. Now, this is a bold claim, and the scientists behind it are careful and honest about that. One of the researchers stressed that this kind of modeling, reaching back over 4 billion years and nearly 3,000 kilometers down, can never be 100% certain. We can't go there and take a sample, and the basic idea that the blobs might be related to Theia wasn't entirely brand new. But what made this study land like a thunderclap was that, for the first time, it took that wild notion and showed, with detailed physics simulations, that it could actually work, that the numbers add up, that Theia's material really could have sunk and survived and accumulated into exactly the kind of blobs we see. One planetary scientist put it well, saying this was the first work to make the idea something you could take seriously, rather than just a throwaway thought. And the implications go even deeper, because this isn't just a story about a cosmic murder mystery. It might be a story about why you exist. Here's the truly mind-bending part. Those blobs deep inside the Earth aren't just inert lumps sitting there. They're hot, and heat inside a planet drives movement. Many scientists think the blobs play a role in generating mantle plumes, gigantic columns of hot rock that rise up from the deep mantle all the way to the surface, where they fuel volcanic hotspots and shape the face of our world. These plumes are no small thing. They're thought to feed some of the most dramatic volcanic features on the planet, the kind of deep-rooted hotspots that build island chains and, in the distant past, unleashed staggering outpourings of lava across whole regions. And the edges of the blobs, where the hot material meets the normal mantle, seem to be the launching pads for many of these rising columns. So if the blobs really are Theia, then a dead planet buried in our depths may still be reaching up through 3,000 kilometers of rock to shape volcanoes, islands, and eruptions at the surface today, quietly steering the geology of the world long after its own death. The corpse, in other words, is not entirely still. It may still be moving the Earth. And some researchers go further still. The 2023 work and the ideas around it suggest that the arrival of Theia's material and the heat and churning it introduced may have helped kickstart plate tectonics, the slow, grinding dance of the Earth's surface plates. And plate tectonics is no minor detail. It's thought to be deeply connected to why Earth has a stable climate, recycled nutrients, continents, and oceans over billions of years, the very conditions that allowed life to take hold and flourish. In other words, the dead planet buried in our depths may not just be a relic. It may have been the spark that made Earth a living world. Think about the strange beauty of that. The collision that nearly destroyed the early Earth may also have been the event that gave it a moon, set its continents in motion, and ultimately made it habitable. The same catastrophe that killed Theia may be the reason there's anyone here at all to dig up its grave. Theia didn't just die in that impact. In a sense, it gave its body to build the world we live on. Pieces of it became the moon that lights our night sky. Other pieces sank into our depths and may have stirred the engine that makes our planet alive. We are, in a very real way, walking around on the blended remains of two worlds. So the next time you look up at the moon, remember that you may be looking at the scattered face of a lost planet, and that more of it is hidden beneath your feet, two vast tombstones of an alien world resting in the dark near the center of the Earth. We've only just begun to understand them. We don't yet know everything they did to us, or everything they might still be doing, far below, where no drill will ever reach. The corpse of Theia is down there right now, silent and enormous, and it has been keeping secrets for 4.5 billion years.